Right now, inside the Black Canyon of the Colorado River, something is happening within one of the most powerful structures humanity has ever built. It is not a hairline fracture. It is not a surface imperfection. It is a structural fissure, expanding at 4 inches per hour inside the monolithic body of Hoover Dam. Engineers monitoring the readings cannot explain the acceleration rate. Geologists studying the fault system beneath the dam are using a word they almost never use: unstable. 40 million people downstream have no idea. Hi, my name is Daniel, and this is Natural Disasters. This is a crack that shouldn't exist. March 17th, 2026, 5:42 in the morning, Mountain Standard Time. A routine vibration sensor embedded in the downstream face of Hoover Dam's central spillway section transmits a data packet to the Bureau of Reclamation's monitoring hub in Boulder City, Nevada. The reading is flagged automatically, not because anyone is watching at 5:42 in the morning, but because the algorithm watching for anomalies has never seen a number like this before and does not know how to do with it. The on-call engineer receives an automated alert on her phone. She reviews the data. She calls her supervisor. Her supervisor calls his supervisor. By 6:15 in the morning, a 4-person structural assessment team is already driving towards the dam in the dark. What they find when they arrive stops them at the access corridor entrance. A crack running along the interior of the dam's downstream face in the Penn Gallery section between elevation 750 feet and elevation 722 feet has propagated in a direction that the dam's structural design explicitly assumed it could not. Not vertically, not horizontally, diagonally, at a 23-degree angle, cutting through the compressive stress zones that are supposed to be Hoover Dam's most structurally redundant sections. The crack measures, at initial assessment, 31 inches in total visible length. The depth probe readings are worse. Ultrasonic pulse velocity testing conducted at 6:58 in the morning reveals the fracture extends at least 9 feet into the dam's interior concrete mass, possibly further. The deeper sections are producing echo signatures that suggest cavity formation behind the primary crack face. By 8:30 in the morning, the Bureau of Reclamation has escalated the incident to a Priority 1 structural emergency. The term used in their internal communications is structural integrity concern requiring immediate intervention assessment. That is bureaucratic language. Let me translate it for you. Something is wrong inside Hoover Dam, and nobody yet knows how wrong. By 9:15 in the morning, the crack has grown. The measurement team records the fracture at 34.5 inches in length. That is 3.5 inches of propagation in approximately 2 hours and 15 minutes. By noon, the rate has accelerated. The reading that sends the emergency notification up to the Department of the Interior and triggers federal involvement is recorded at 12:47 in the afternoon. The crack now measures 41 inches. The rate of expansion calculated over the previous 3 hours is 4 inches per hour. 4 inches per hour. It is continuous, accelerating, and happening in a structure holding back 9.3 trillion gallons of water. Most people do not fully appreciate Hoover Dam until they stand at the top and look down. It is not just big. It is comprehensively, almost offensively large, in a way that makes your brain argue with your eyes. The dam stands 726 feet tall, taller than the Washington Monument. Its base is 660 feet thick. You could lay 2 full American football fields end to end inside the base of this dam and still have room left over. It contains 3.25 million cubic yards of concrete, enough to pave a 2-lane highway from San Francisco to New York City and halfway back again. It is the physical proof that human beings can impose their will on a river that carved the Grand Canyon. It is the reason Las Vegas exists. It is the reason agriculture functions across the American Southwest. And right now, a crack inside it is expanding at a rate that suggests the load transfer system keeping the entire structure standing is actively failing. The clock is no longer just ticking, it is screaming. By 2:15 in the afternoon on March 17, 2026, the situation inside the Black Canyon has transitioned from a structural anomaly to a geophysical crisis. While the Bureau of Reclamation's engineering teams are deep inside the dam's galleries, a separate set of alarms is being triggered at the USGS Earthquake Science Center. High-frequency seismographs located in Boulder City and at the Nevada test site begin recording a phenomenon that geologists call harmonic tremors, sustained rhythmic vibrations typically associated with fluid movement or catastrophic structural failure. But there is no magma here. There is only the weight of 25 million acre-feet of water and the ancient, brittle rock of the Basin and Range Province. At 3:40 p.m., the Nevada Geodetic Laboratory at the University of Nevada, Reno releases a flash report based on GNSS, Global Navigation Satellite System data from station NV-HD1, anchored directly into the canyon's west abutment. The data shows a lateral offset of 14 millimeters, occurring over the previous 6 hours. In the world of geodesy, where shifts are usually measured in millimeters per year, a 14 millimeter jump in 6 hours is a tectonic heart attack. This isn't just the dam cracking, the very foundation of the Black Canyon is shifting. Dr. Sarah Jenkins, a lead seismologist with the USGS, issued an internal briefing at 4:22 p.m. that was later leaked to the press. Her words were chilling. The seismic signatures we are seeing are not traditional tectonic aftershocks. We are observing deformation-induced seismicity. The canyon walls, which act as the mechanical anchors for Hoover's arch gravity design, are experiencing a brittle failure event. The crust in this region is being pulled apart by the extension of the Basin and Range Province, and the dam, this massive rigid plug of concrete, is caught in the middle. It is trying to hold together two pieces of the earth that no longer want to be connected. To understand why this is happening, you have to look at the coupled systems of the Colorado River. For 90 years, the weight of Lake Mead has pushed down on the Earth's crust, a process known as reservoir-induced seismicity. But over the last decade, as the mega-drought depleted the reservoir to historic lows, that weight was lifted. The crust began to rebound upward, like a spring being released. This unloading has reactivated ancient, dormant faults within the Las Vegas Valley Shear Zone, a complex system of fractures that run within 5 miles of the dam. By 6 p.m., the Bureau of Reclamation's Denver Technical Center completes a 3D finite element analysis of the fracture. The results are catastrophic. The crack is no longer a simple break. It has become a shear plane. Because it is cutting diagonally through the compressive zone, it is effectively uncoupling the top 200 feet of the dam from its base. The hydrostatic pressure from Lake Mead is no longer being transferred into the canyon walls. It is being concentrated directly onto the remaining uncracked concrete. The technical report from the 6 p.m. briefing, B-REC Technical Memo 26-03-A, states, current stress-strain models indicate the factor of safety for the central spillway section has dropped from 3.0 to 1.14. Any further propagation of the fissure beyond the 50-inch mark will result in a loss of arch action. In this state, the dam would rely solely on its weight, its gravity component, to resist the 30,000 pounds per square foot of water pressure at the base. Our model suggests the gravity component alone is insufficient to prevent sliding failure or overturning if the fracture reaches the upstream face. As the sun sets over the Nevada-Arizona border, the tension at the dam site is palpable. Floodlights have been erected along the downstream face, casting long, haunting shadows against the 726-foot concrete wall. At 7:55 p.m., another sensor, this one a tilt meter located at the 500-foot elevation mark, records a sudden 0.02 degree lean toward the downstream side. It is a movement so small that a human couldn't feel it, but it represents billions of tons of concrete beginning to yield to the river. This is not a slow-motion event anymore. says Dr. Robert Vance, a structural consultant with the Army Corps of Engineers, in a recorded transcript from the 8:30 p.m. emergency conference. At 4 inches per hour, we are watching the structural evolution of a collapse in real time. If you compare this to the Teton Dam failure of 1976, we are currently in the incubation phase, just before the breach phase. The difference is that Teton was an earthen dam that failed in minutes. Hoover is a concrete monolith. If it goes, it won't just wash away. It will shatter under the internal tension, sending concrete blocks the size of apartment buildings into the canyon at 80 miles per hour. The vulnerability of the Southwest's infrastructure cannot be overstated. Hoover Dam is the linchpin. It doesn't just store water, it regulates the entire Pacific Southwest power grid. The 17 generators in the powerhouse produce 2,000 megawatts of electricity, enough to power 1.3 million homes. But the power is irrelevant if the structure fails. By 10 p.m. on March 17th, the crack is measured at 48.5 inches. It is only 1.5 inches away from the mathematical red zone. The word unstable is no longer just being whispered by geologists. It is being written in bold letters on the situation boards at FEMA Region 9 headquarters in Oakland. The countdown to 72 hours has become a countdown to the potential end of the American Southwest as we know it. The weight of history is heavy, but the weight of concrete is absolute. To understand the terror currently gripping the engineers in the Black Canyon, you have to look back at the ghosts of American civil engineering. Every major dam failure in US history has been a hard-learned lesson written in the blood of those downstream. The shadow of March 12, 1928 hangs over the Bureau of Reclamation right now. That was the night the St. Francis Dam in San Francisco Canyon, California, collapsed, just hours after the legendary William Mulholland inspected it and declared it safe. 12 billion gallons of water surged over the Pacific, killing at least 431 people and ending Mulholland's career. The cause? A defective foundation in the paleo hillsides, a geological instability that mirrors the exact microfracturing Dr. Rachel Morrison is seeing in the Arizona-Nevada canyon walls today. But Hoover was supposed to be different. Hoover was the peak of the American century. However, science has a way of revealing vulnerabilities that the engineers of the 1930s simply couldn't have seen. We are talking about the silent killer of infrastructure, alkali silica reaction, or ASR. In the 1930s, the Bureau of Reclamation used whatever aggregate was closest to the site. They didn't know that the volcanic rocks of the Black Canyon were rich in reactive silica. When that silica meets the highly alkaline environment of wet concrete, it forms a hygroscopic gel. That gel absorbs water, expands, and exerts internal pressures exceeding 1,000 pounds per square inch. It's essentially a slow-motion explosion from the inside out. For 90 years, this concrete cancer has been growing, turning the dam's monolithic strength into a brittle, pressurized honeycomb. Statistical models run by the Denver Technical Center on the morning of March 18, 2026, suggest that the 4-inch per hour crack isn't just a mechanical break. It is the final catastrophic release of 90 years of ASR-induced tension. The seismic maximum credible event, MCE, for Hoover Dam was always calculated based on external earthquakes. No one built a model for an internal collapse, driven by chemical expansion coupled with the isostatic rebound of the Earth's crust, as Lake Mead's water levels fluctuated during the Great Southwest Megadrought. Look at the data from the 1983 Colorado River flood. Back then, Hoover Dam faced its greatest test when the spillways were nearly destroyed by cavitation, the process where fast-moving water creates vacuum bubbles that explode against concrete, tearing it apart like wet paper. In 1983, the dam held, but it revealed a truth that engineers have whispered ever since. When water moves that fast, concrete is just a suggestion. Now, in 2026, we aren't dealing with water tear in the surface. We are dealing with the internal skeletal structure of the dam snapping. The USGS National Seismic Hazard Model for the Basin and Range Province has recently been updated to account for crustal thinning. This is the science. The American West is literally being pulled apart. The El Dorado Valley fault system, just a few miles from the dam, is a normal fault, meaning one side drops while the other rises. Geologists are now investigating if a subvisual slip, a movement so slow it didn't register as a sharp earthquake, has shifted the canyon floor just enough to pinch the arch. In arch gravity dams, geometry is everything. If the arch is pinched, the internal stresses don't just increase, they redistribute in ways the 1930s slide rule calculations never accounted for. The Bureau's current Scenario 2 model, the one assuming the 4-inch per hour rate continues to accelerate, uses a terrifying phrase, iterative structural unraveling. This means the failure of one section of the dam increases the load on the next section so quickly that the entire structure begins a cascading fracture sequence. It's a domino effect made of 3 million cubic yards of concrete. The historical parallels to the Teton Dam failure in Idaho in 1976 are equally haunting. Teton failed during its first filling because of piping, internal erosion. While Hoover is concrete, not earth, the diagonal crack discovered at 5:42 a.m. is acting as a massive pipe. Hydraulic pressure is forcing Lake Mead's water into that 9-foot deep fracture at thousands of pounds of pressure. This is hydraulic wedging. The water itself is now acting as a lever, prying the crack open further and further. Every minute that passes, the water wins. By 1 p.m. on March 18th, the Bureau of Reclamation has released a Condition Red internal memo. In the history of the Colorado River, the water has always been the prize. Now it is the weapon. The science tells us that the factor of safety has been breached. The historical parallels tell us that when these structures go, they don't give you a second chance. We are watching the first potential total system failure of a Tier 1 US national infrastructure asset, and the clock is down to 41 hours. The statistics are staggering, but the human reality inside the Black Canyon is a nightmare of vibrating steel and screaming concrete. Mark Thayer, a third-generation Bureau of Reclamation maintenance supervisor, has spent 22 years in these galleries. He knows the language of Hoover Dam, the subtle hum of the turbines, the cool, damp breath of the ventilation shafts. But on the afternoon of March 18, 2026, the dam is speaking a language he doesn't recognize. It sounds like a freight train is passing through the wall 3 inches from your ear, Thayer said in a frantic radio dispatch at 2:14 p.m. It's not a hum anymore, it's a rhythmic grinding. Every time the sensors tick up another hundredths of an inch, the whole gallery shudders. We are pushing resin into the fissure, but the pressure is pushing it right back out. It's like trying to plug a gunshot wound with a garden hose, while the victim is still running a marathon. The Hoover Scream, as the workers are now calling it, is the sound of 3.25 million cubic yards of concrete undergoing brittle failure. Inside the Penn Gallery, between elevations 750 and 722, the air is thick with the smell of wet alkaline dust and the chemical tang of the high-pressure polymer resins. Thayer and his team are working in 120-degree heat, draped in safety harnesses, drilling into a face that is actively moving. Every few minutes, a spall, a chunk of concrete the size of a dinner plate, shears off the wall and shatters on the gallery floor. This is the physical reality of a structure losing its fight against 9.3 trillion gallons of water. Outside the dam, the human domino effect has already begun. In Laughlin, Nevada, and Bullhead City, Arizona, two communities that sit directly in the shadow of the dam, the atmosphere is one of controlled panic. Marcus Whitman, the emergency coordinator for Mojave County, Arizona, issued a voluntary evacuation advisory at 3 p.m. It wasn't mandatory yet because the Bureau of Reclamation hadn't officially declared a potential failure mode, but the people aren't waiting for the paperwork. The I-15 corridor and US 95 are already choked with vehicles. In the Mojave Desert heat, cars are overheating, and the cellular network is beginning to buckle under the weight of 200,000 people trying to call their families at once. We are looking at a logistical impossibility, Whitman noted in a recorded briefing for the Arizona Division of Emergency Management. If the breach occurs in the Scenario 3 timeframe, under 4 minutes, there is no evacuation. There is only high ground. We have marked a blue line on the canyon walls in Bullhead City. If you are below that line and the sirens go off, you have roughly 90 minutes to get 60 feet uphill. But for the elderly in the nursing homes along the river or the families at the Big Bend State Recreation Area, 90 minutes isn't enough time to move 1,000 people. The stakes extend far beyond the flood zone. The American Southwest operates on a water energy nexus. If Hoover Dam's generators go dark, the Western interconnection, the massive power grid serving 14 states, loses its primary black start capability. David Nakashima, a senior grid operator at the California Independent System Operator, CAISO, in Folsom, explained the risk. Hoover is our anchor. It's the facility we use to kickstart other plants if the grid goes down. If we lose Hoover's 2,000 megawatts instantaneously, we are looking at a frequency collapse that could trigger rolling blackouts from Seattle to San Diego. We are talking about 30 million people losing power within seconds of a dam breach. But the most devastating long-term impact isn't the power, it's the water and the food. In the Imperial Valley of California, Maria Rodriguez, a second-generation vegetable farmer, looks at her fields of winter lettuce. The Imperial Valley produces 80% of the United States' winter vegetables. Every drop of water that sustains this multi-billion-dollar industry comes from the All-American Canal, which is fed by the Colorado River downstream of Hoover. If the dam fails, the flood destroys the canal systems. If the flood doesn't get us, the silence will, Maria says. Once Lake Mead is gone, there is no more water for the crops, no water for Yuma, no water for the 15 million people in Los Angeles who rely on the Colorado River aqueduct. We aren't just talking about a flood, we are talking about the permanent dehydration of the American West. As of 5 p.m. on March 18th, the total economic damage estimate from FEMA has been revised upward to $1.2 trillion. This includes the loss of the dam, the destruction of downstream infrastructure, the collapse of the regional agricultural economy, and the multi-year disruption of the Pacific Southwest power market. But for Chloe Henderson, a 19-year-old student at UNLV whose family lives in a low-lying trailer park in Needles, California, the numbers don't matter. My dad won't leave, she says, her voice breaking over a choppy 5G connection. He says the dam has stood for 90 years, and it will stand for 90 more. He doesn't see the crack. He doesn't hear the scream. He just sees the river, and he thinks the river is his friend. He doesn't understand that right now the river is a 700-foot tall wall of water waiting to happen. The 72-hour window is now at the 36-hour mark. Inside the dam, Mark Thayer and his crew have just finished installing the 10th anchor bolt. The crack has reached 52 inches. The propagation rate has plateaued at 3.6 inches per hour, but a new sensor at the upstream face has just recorded a moisture spike. Water is beginning to seep through the concrete from Lake Mead. The hydraulic wedge is no longer a theory. The river is starting to find its way through. The 72-hour window is not a timer on a bump. It is the expiration date of an era. As the clock ticks toward the morning of March 20th, 2026, the structural reality inside Hoover Dam has shifted from an engineering challenge to a permanent geopolitical fracture. Even if the high-pressure resin holds, even if the 14 massive steel anchor bolts successfully squeezed the fissure into temporary submission, the American Southwest has already changed. The Bureau of Reclamation's Denver Technical Center has issued a classified preliminary report titled Long-Term Viability of the Colorado River Storage Project under Accelerated Structural Degradation. The conclusion is a death knell for the status quo. Hoover Dam can never again be allowed to hold Lake Mead at full capacity. To save the structure, the reservoir must be brought down to dead pool levels, elevation 895 feet, where water can no longer flow through the intake towers. This isn't just a safety measure, it's a total decommissioning of the most vital water resource in the United States. Las Vegas, a city that draws 90% of its water from these depths, would have to survive on third-stage pumping stations that were never designed for permanent sole source operation. The Southern Nevada Water Authority is already modeling a zero-growth mandate that would effectively end real estate development in the Mojave Desert overnight. But the risk isn't localized to Nevada. The infrastructure contagion is what keeps the Department of Homeland Security awake. Hoover Dam is the eldest sibling in a family of aging giants. The average age of the 91,000 dams in the United States is 57 years. Most were built with the same 20th century optimism and the same lack of understanding regarding long-term chemical reactions like alkali-silica reaction, ASR. If Hoover, the gold standard of American engineering, is failing from the inside out due to concrete cancer and crustal rebound, what does that mean for Glen Canyon Dam upstream? What does it mean for the Oroville Dam in California, or the massive earthen works of the Mississippi River Valley? Dr. James Parks' theory on ASR is no longer a fringe hypothesis. It is the leading edge of a new field of forensic infrastructure geology. In his final briefing to the National Security Council on the evening of March 19th, he stated, "We are witnessing the geological reclamation of the American West. We built these structures during a unique 100-year window of climatic and seismic stability. That window is closing. The crustal extension of the Basin and Range Province doesn't care about our 90-year-old concrete. The river doesn't care about our 72-hour windows. We have treated the Colorado River as a plumbing system, but it is a tectonic force. When the Earth moves 14 millimeters in 6 hours, the dam isn't an obstacle. It's a brittle inclusion in a moving mess." The power grid implications are equally permanent. The Palo Verde Generating Station in Arizona, the largest nuclear power plant in the United States, relies on a complex system of water rights and cooling exchanges linked to the stability of the Colorado River's flow. If the hydraulic domino effect wipes out the downstream dams like Davis and Parker, the cooling logistics for the entire southwestern energy corridor enter a critical failure state. We are looking at a future where the tectonic fury of the Black Canyon forces a retreat of civilization from the desert floor. As of 4 a.m. on March 20th, the 72nd hour, the crack in the Penn Gallery has reached a length of 58 inches. The propagation rate has slowed to 1.1 inches per hour, the result of the 14th anchor bolt being torqued to its maximum capacity. The engineers have won for now. They have stopped the immediate breach, but the victory is hollow. The dam is stable only in the sense that it hasn't collapsed yet. It is a crippled giant. The Bureau of Reclamation has begun the emergency drawdown protocol. The spillways, which haven't seen major use since 1983, are being prepped to roar. They will drain Lake Mead at a rate that will flood the downstream banks for months, just to take the pressure off the cracking heart of the dam. The follow the data mantra of the USGS has led us to a haunting conclusion. The crack that shouldn't exist was never the problem. It was the symptom. The problem is the assumption of permanence in a world defined by change. We have built our cities and our lives on the back of a concrete wall that is now screaming under the weight of the earth itself. The 40 million people downstream may have escaped the flood today, but they are waking up to a different world, a world where the water is no longer guaranteed, a world where the linchpin has snapped. Hoover Dam remains standing in the Black Canyon, a scarred monument to human ambition, but the scream hasn't stopped, it has just changed frequency. The geologists are still watching the tilt meters, the engineers are still watching the resin, and the river that carved the Grand Canyon through 2 billion years of rock, is simply doing what it has always done. It is waiting. The data doesn't lie, and the data says that the clock isn't at zero yet. It has just started a new, much longer countdown. This is the reality of our infrastructure in 2026. This is the inevitable intersection of human engineering and tectonic force. My name is Daniel, and this is Natural Disasters. Follow the data, because the Earth always does.